On the review sheet for 1272, review sheet number 3, let's move on to number 1, parts C and D. The probability that a randomly selected individual spends more than 2.4 hours, and then the probability that a randomly selected individual spends less than 1.9 hours. On a normal distribution problem, when you are trying to find the probability that a randomly selected element falls in a certain category, more than 2.4, less than 1.9, what you're essentially trying to find is the area underneath the normal distribution in between two boundaries. More than indicates that the boundary is going to start somewhere and it's going to basically trail off into infinity towards the right. So we'll draw our normal distribution curve. We'll center it at our average. We'll put in our data value that the problem is asking for. And again, the data value has to be based upon the location of the middle, right? 2.4 is less than 3, which means that 2.4 is going to be placed to the left of 3. And then we'll shade in everything to the right all the way to the end, the right-hand side, because this says more than, which indicates everything from 2.4 all the way up to infinity. So let's figure that out. Right, our normal CDF function, once again, indicates it wants a lower boundary, which will be 2.4. It wants an upper boundary, which in this case will be infinity. And infinity you can put into your calculator as 1, and then the letter capital E. There's a second function of number 7, I think it is. I'll show you later. That says 2 capital E's. That's the E I'm interested in. And then 99, which is basically the calculator's way that this number is 1 times 10 to the 99th power. Then the average, then the standard deviation. Let's take a look over here. So let's clear this off. We'll hit second, and then the distribution function. We'll find normal CDF. Lower boundary is going to be 2.4, comma. The upper boundary is going to be infinity. So there's a capital E. If you look at these letters, if you hit alpha and then the sign button, that's a capital E. We don't want that one. If you hit second and the division button, that's a lowercase e. That's actually the number 2.718, blah, blah, blah. We don't want that one. Right, what we want is the 2 capital E's, the EE symbol. So that's going to be second and comma. This one shows it as a lowercase e, but just rest assured that this is the one we want, right? So let's hit 1, then second, comma, to get that scientific notation, and then 99, and that is the calculator's way of basically writing the number infinity. The mean is 3, standard deviation is 0.5, close that up, hit enter, and then we get a value of 0.885, rounded off to 3 decimals. And that is exactly what we see right over here. Moving on to part D, the main difference in this question, aside from the data value it's asking for being different, the main difference here, it says the words less than that data value, so strictly less than. So let's draw the same normal distribution curve, center it at 3, and this time we're going to put a data value of 1.9, still to the left of 3 somewhere, and we'll shade in this time the area to the left of this because it says less than. So the normal CDF function now is going to have a negative 1 E99 for the lower boundary, 1.9 for the upper, and then 3 and 0.5, the same as before. So if we hit second and entry, that's going to give us what we got. That's going to give us what we put in before. And now we can put in a negative 1 to the 99th power, comma, 1.9 as our upper boundary. Remember, the negative button is next to the decimal point on a TI calculator. Not the same as the minus button for subtraction. So 0.014 is our probability. Right, the probability that a data value is going to fall in this region is about 1.4%.